In the last section, we saw that the area of a rectangle is the base times the height. In this section, we're going to look at parallelograms and triangles. If I have a parallelogram, I could drop an altitude down, and then I have a right triangle. If I take that section of the right triangle and slide it over to the other side, I've now formed a rectangle. So the area of a parallelogram is just the area of the base times the height. And remember, height is always measured on a perpendicular. The area of a triangle is 1/2 the base times the height. If we doubled the triangle and flipped it on itself, we'd have a parallelogram, and thus the prior information applies. Here are a couple of examples to determine the area of the triangle. My big hint to you is highlight the altitude. So then you have the base times the height, which is 150 divided by 2, which is 75. The base times the height, 56 divided by 2, is 28. We can look at some more examples in a moment. So to find the total area of each figure, again, this reverts back to finding the area of irregular shapes. I'm going to do the triangle first, which is 1/2 of 7 times 4, and I'm going to add that to the area of the rectangle. So 1/2 of 4 is 2 times 7 is 14, and 21 gives me 35. Look for the set of perpendicular lines when you're trying to determine what to use as a base and a height. So here I'm going to have 1/2 of 12 times 9 plus 6 times, oh, wait a minute, we don't know this distance here. 3 times 3 is 9, 3 times 4 is 12. This must be 3 times 5, or 15. So 1/2 of 12 is 6 times 9 is 54. 60 plus 30 is 90. We add those together, we get 144. Find the area of an isosceles triangle whose sides are 10, 10, 16. Remember, when I drop the altitude down, it's also the median in an isosceles triangle. So here we have 8 and 8. So 1/2 of 16 times whatever this height is. That's 2 times 4. That's 2 times 5. That must be 2 times 3. So 8 times 6 is 48. Find the base of a parallelogram whose height is 3 and area is 42. So if the area is equal to the base times the height, then the area, 42, is equal to the base times the height of 3, which means in order to find the base, we take 42 divided by 3, which means the base is 14. Find the area of each triangle. In this first example, we see that we have a 30, 60, 90 triangle. So I'm going to go ahead and set up my tic-tac-toe board. Recall that the ratio of the sides is x, x root 3, and 2x, and the side across from 90 degrees is 12. So if 2x equals 12, then x is 6. So that means that this side is 6, this side is 6 root 3. So 1/2 of 6 times 6 root 3 is 18 square root 3. This triangle here is a 45, 45, 90, because if the sides are congruent, then the angles across from those sides are also congruent. So if I set up my tic-tac-toe board, or if you can see it right away, that's fine too. If that's 12 root 2, then x is 12. So we have 1/2 of 12 times 12, or 72. In this triangle, we have an equilateral whose sides are 12. Remember that if I drop down the altitude, it's also the median. So then that creates a 30, 60, 90 triangle. So that's 6, and that altitude there is 6 square root 3. So then I have 1/2 of 12, because I want the entire base, times the height of 6 square root 3. So I have 36 square root 3. Find the area of each trapezoid by dividing it into a rectangle and a triangle. So I want the area of the triangle plus the area of the rectangle. If this larger base is 14 and the upper base is 10, that makes that side 4. That height is given as 7. So I'm going to have 1/2 of 4 times 7 plus 10 times 7. So I have 2 times 7 plus 10 times 7. 14 plus 70 is 84. If the lower base is 19 and the upper base is 13, the difference is 6. Given this is an isosceles trapezoid, then I know that 6 needs to be distributed equally. So that distance is 3, that distance is 3, and that's 13. So then I'm going to have 2 triangles plus the rectangle. 2 times 1/2 of 3 times 8 plus 8 times 13. That cancels each other out, so now we have 24 plus 80 and 24. To find the area of the shaded region, I'm going to want the rectangle minus the triangle. The rectangle is 10 times 17. The triangle is 1/2 the base times the height. So I have 10 times 17 minus half of 10 is 5, which gives me 5 times 17, 35 plus 50 is 85. When I look at this diagram, I immediately want to focus on the perpendiculars. They gave me PS, they gave me QT, and they gave me PR. So the two segments that are perpendicular that I know the lengths of are QT and PR. That's what I want to focus on. So the area is 1/2 of 12 times 15. 60 plus 30 is 90. And then to find the area I know it's 1/2 the base times the height. I already know this area is 90. I'm asked to find RQ, and they told me PS was 10. "90 divided by 5, RQ is 18. Find the area of an equilateral triangle whose perimeter is 45. If the perimeter equals 45, then the side is 45 divided by 3, or 15. Side is 15, drop down the altitude, it's also the median, so that's 15 divided by 2. Then the altitude is 15 square root 3 divided by 2, such that the area is 1/2 the base of 15 times the height, that's 225 square root 3 divided by 4.